today's topic is, can you replace API management with a service mesh? This is a fun topic because it's probably one of the #1 questions that we always get when we are out there talking to folks in the community and companies kind of looking in this modern API space. With the rise of service mesh and Envoy, there's been a lot of questions on like, where does it go? What's a replacement for, what can I replace with this new thing, and how do they work together? So with that, I'd like to hand it over to Christian Posta, our field CTO, to answer the #1 frequently asked question.
That is right. Thank you, Betty. Hopefully you can hear me. And as Betty said, that this is a very common question. And there's a lot to unpack when we start talking about this, because there is an established, and has been for 10 years or so, an established practice and implementation of API management. And there's now this new thing, right? Service mesh. And there's this overlap. And there's overlap in some of the capabilities, but then when you start to dig into the individual technology implementations, there's confusion. And so we're going to try to help you understand what are the different roles that you should be aware of, where these things fit, and what can be replaced with what in terms of this title. So my name is Christian Posta. I work here at Solo. I've been here almost 2 years now. I've been involved my entire career in building services style architectures, building the infrastructure to support them, including in previous life, building the foundational pieces, both in open source and closed source, that kind of looked like what Kubernetes was doing. And then when Kubernetes came along, kind of looked like what the service mesh was doing. And then when the service mesh came along, I mean, both Kubernetes and service mesh, when these things came along, the light bulb went off and said, yeah, okay, that's the thing. We don't need to hand cobble these things together anymore. And I've worked with teams, worked with organizations all over the world to help build these types of cloud applications and leverage these cloud infrastructure to build things like microservices, to build things like some of the DevOps tooling and automation that goes on top of that to enable teams to go faster, right? That's the ultimate goal, is to get things out faster. And so I've written about this a lot. I speak about this, and I work very closely with customers and prospects on these types of problems. You can reach out to me if you have any questions in this space generally about any one of these particular technologies or anything that I talk about today. So do feel free to reach out. So at Solo, what we are doing is we're helping folks connect their applications and do that in a way that aligns with the way people are adopting cloud infrastructure. And so that means the problem sets are not all that new, but the way that they're being deployed and implemented, there is some some differences in what we've done in the past and what we're doing, what we need to do now, right? So our customers, our prospects, they are going from a monolithic style application architecture, but it also organizational structure, to these different these different types of models where we're decentralizing the architectures, the implementations, and the processes. And we're doing that to decouple the friction points between teams so that they can take advantage of cloud infrastructure and some of this new tooling that's becoming available to go faster, right? And so some of those challenges in terms of connecting applications are around security, are around understanding when things go wrong, because this is now a very fluid, ephemeral, complex architecture. Having deep understanding of what's happening at runtime is very important. And then, still solving those similar problems where you need to expose APIs, have folks discover them, self-service, enable this autonomy for the teams. And so these are the challenges that our customers are facing. And we're looking at it from a solutions standpoint. We're not looking at trying to fit product into, round product into square peg, right? Square hole. We're figuring out what is it that they're trying to solve. And that could be global routing. That could be global type of failover. That could be managing calls between on-prem and in a public cloud, or between two public clouds, and solving those challenges holistically. So coming back to the talk here, the inspiration for this, or rather the background information for this, I've documented and written about this quite a bit over the last few years. And if you go check out the blog at Solo, or my own personal blog, these are things that I've gone into some fairly gory detail that I'll try to extrapolate into a webinar format for you here. So it basically comes down to this. As we start to build our applications onto cloud infrastructure, which is by its nature very ephemeral and elastic, it could be scaling, it can be adding new nodes, the nodes could be failing, the nodes could be orphaned. This is very different than what we saw in previous generations of technology, where things were much more static. And there was an assumption that the machines would never go down, the databases would never go down, and everything was highly redundant, highly available, and so forth. And they did go down, and the applications were not equipped to deal with that. So in this new model, this elasticity and ephemerality is a first-class design point when we build our applications. Second thing is, as we start to go to more of a decoupled or microservice style architecture, there's a lot more connectivity points. And these connectivity points are going over things like software-defined networks, cloud-owned networks, so not even your own network, sometimes the internet, and the fallacies of distributed computing come roaring forward, right? Now, like I said, some of these problems are not entirely new, just the context is different. In the past, we would do things like put these appliances in the middle of our architecture and force all of the traffic through that, right? So you had things like, going back a little whiles, you had enterprise application integration, you had things like enterprise service buses, you had both software-based things like WebSphere ESB and or appliance-based things like data power and so on. And the idea was, if we could just force all the traffic through this box, that we can see it, we can control it, we can secure it, and that will solve some of these challenges that we face when applications need to talk with each other. And out of some of those previous generations of technologies came, well, a lot of that's complicated, trying to deal with the protocol translations and all that stuff in ESBs. Why don't we just go everything to REST? We'll move everything to REST and JSON and HTTP, and we'll expose APIs, and everything will be perfect that way. And that gave rise to the API management solutions, right? And so API management specifically was to solve some of that evolution of the technology stack and how we wanted to present that to other parts of the organization, other partners, external users. And so API management grew up in a way to solve some of those challenges around both exposing the APIs, managing who can use them, as well as things like the security, the security and communication challenges around authorizations, rate limiting, telemetry collection, and so forth. And then start to build capabilities on top of that in such a way that allows you to monetize API usage, implement chargeback within your enterprise, and these types of things, which is all very useful and important, right? So some folks adopted more of these different parts of API management than others, but these all the core of API management is still, you know, it has a lot of value. Now, as you know, we went from this to, you know, API management solutions came on board. Unfortunately, they got implemented in a very similar way that the previous generations of technology was implemented. And when I say unfortunate, I don't mean because it was bad, but I mean because that model doesn't fit with the cloud model, with the elastic ephemeral model, and the decentralization of processes and so forth, right? So the implementation worked out great back then, but it doesn't fit what we're trying to do now. And you know, some of the things that crop up are around the fact that this type of technology is typically implemented in a very centralized manner. And when I say centralized, I mean both from a technology standpoint. Calls go from a service to another service through this box, and as well from a ownership standpoint. You have a specific API platform team that typically runs these large, complex, resource-intense API management tools. But you also have your processes aligned and tied to this centralization. If you need to make a change to the way routing is done or filtering is done or any of that stuff on the API management tool, you have to file tickets and coordinate and do all this stuff. There was no, you know, the decentralization of the process wasn't the first class design in these more legacy API management vendors. The last thing I'll say is, in terms of the evolution of technology, these solutions were built on older technologies, which again in itself is not the bad thing, but it wasn't designed to fit in this highly dynamic and elastic environment. So for example, we know of customers that we work with that have replaced their legacy API management with something more modern. And some of those use cases were driven by the fact that the technology was not equipped to handle things like circuit breaking or isolation of noisy neighbors, and could get into situations where the tail latencies and the latencies that would crop up because it was built on something, let's say, like Java, or you know, some other technology that needed to garbage collect in the middle of processing, right? So from a performance, from a isolation, from a dynamic environment and the capabilities you need, these API management tools were built on legacy technology that wasn't built to survive in that arena. So let's fast forward a little bit, right? We said that API management has a lot of value. We see how in enterprises, large enterprises, it might have been adopted or implemented, and some of the challenges of that. Now, if we fast forward a little bit to the service mesh, right? Service mesh is sort of it's implemented in a highly decentralized way. So it kind of attacks some of these the shortcomings of existing API management. But it's not just decentralized. It was built specifically to handle and to be a part of the solution to services communicating with each other in a cloud environment. Now, what we're seeing, and you might have to ask yourself the same thing, is what we're seeing is the pendulum swing dramatically from one end all the way to the other. And now the service mesh ends up being the hammer that we use to try to fix everything. Now with a service mesh, the salient points of the service mesh, how it fits, juxtaposed to API management, is that the service to service communication now happens end to end between the services. Doesn't have to take additional hops. You still get the ability to observe the traffic, to control the traffic, and secure the traffic. And actually, you can secure it at a layer much lower now than the gateway can. So the service mesh ends up coming into the discussion when people start talking about what does the modern architecture look like, and can we replace the API gateway or the API management solution? So let's take a little bit closer look at what the service mesh is doing. In the service mesh, what we're saying is deploy a little agent next to each application instance. And this agent will be responsible for things like timeouts and retries and circuit breaking, telemetry collection, client-side load balancing, service discovery, right? So this little agent, or this little proxy, solves challenges that were previously solved by centralized middleware, and they do it in a way that's highly decentralized. It's basically co-located with the app. It is the app, right? So this little agent, this little proxy, lives with the app and starts to process requests, the same as the app, and shuts down and terminates or becomes unavailable, just the same as the app, right? So just think of it as a component of the application that just happens to run outside of the application itself. So network traffic goes through this proxy and will arrive at other services, potentially with that proxy. Could arrive at databases, message queues, caches, that kind of thing. So this proxy is intended to intercept from the application or to the application any of the network traffic. And from there, we can write authentication, authorization policies about the traffic. We can observe it. We can enable transport security like mutual TLS. We can assign identity to the different workloads and not rely on IP addresses and firewalls and that kind of stuff. Excuse me. So the service mesh technology is a solution to problems that are not new, but the context is different and solves those problems a little bit more elegantly, especially for the service to service communication use cases. So a typical service mesh might provide these capabilities: service discovery, like I mentioned, traffic control and shaping and traffic shadowing and these types of things, load balancing, and also provides a nice programmatic or API to drive the behavior. So you can write automation on top of this. Things like canary releasing, things like debugging tools, things like security, reacting to security events and so forth. So the service mesh provides a lot of value for services communicating with each other. Now, so we've taken a look at the API management, where it fits, some of its drawbacks in previous implementations. We looked at the service mesh and sort of the evolution. I made the point that the pendulum is swinging from one end, like we like to do in technology, all the way to the farther side of the other end. And then people see these capabilities of the service mesh and they say, yes, that is going to solve everything when it comes to deploying services and managing the communication around them. So that brings us to the question, can you replace API management with the service mesh? And the answer is not exactly. There are missing pieces that the service mesh does not do. And some of those are listed here. And it's typically around, how do you get untrusted traffic to your services And what are the policies that enterprises expect to be able to enforce and implement, to be backward compatible with, to conform to compliance and regulatory practices and so forth? What are those capabilities, and does the service mesh do them? And the answer is not really. Service mesh doesn't cover all of these use cases. So then the question is, well, how do you get there then? So the service mesh brings a lot of good capabilities. The model that it has, the decentralized model, the focus on declarative configuration, these things are really good. But the capabilities that we need, the holistic capabilities that we need in an enterprise that's deploying non-greenfield type scenarios across different clouds with the constraints that an enterprise has, how do we bridge that gap? And from our perspective here at Solo, we can take let's start simple and start to build up from that. What is a solution like what would that solution look like? And from a Solo perspective, it definitely starts with a piece of technology that was built to live in this highly dynamic cloud world, and layer on top of that the different roles and responsibilities needed to bridge that gap. So let's take a look at that in a little bit more detail. So Envoy is a proxy. Envoy is a very lightweight proxy that was built at Lyft, the ride-sharing company, specifically to address these types of problems. Living in a cloud world, something maybe like Kubernetes, nodes are coming, going. You need things like service discovery. You need things like load balancing. You need things like telemetry collection, and that's all good. And Envoy can be run at the edge of a cluster, responsible for taking traffic in and routing it to the various backends. And in a second, we'll start talking about some of the capabilities you can layer into Envoy at that part of the architecture, in that role. In this diagram you see here, this is Envoy as the role of a gateway coming for traffic coming into a set of applications. Envoy is also versatile enough that it can play the role of a central or a shared gateway or a middle proxy for a set of applications. So maybe you have different boundaries within your organization and lines of businesses, service teams, whatever the group ends up looking like. And you have additional policies that you might want to enforce, or usage patterns that you might want to enforce specifically for those boundaries. And so Envoy can be used as a middle proxy to implement those types of patterns. And then lastly, Envoy is versatile enough and slim enough to be able to run with the applications themselves. So when applications and services, maybe within, let's say, a line of business, they need to communicate with each other, those applications can go right directly to each other, right? And still get the benefits of load balancing, security, observability, and telemetry collection, et cetera. So Envoy ends up being a fundamental piece to this puzzle. But the puzzle isn't just one thing, right? So even in the scenarios where Envoy is applicable, we see, all right, well, this kind of looks like the service mesh case. This kind of looks like the gateway case between different parts of the organization. Those different parts might be deploying on different types of infrastructure. They might be deploying on different types of clouds, some on-prem, some in a public cloud. And we also see the edge case as traffic comes into a set of services. So Envoy is very versatile, and starts to form the foundation for a solution that is encompassing of what people are trying to do with their application traffic. So the service mesh case here uses Envoy. The gateway case also uses Envoy. So now this is where, in the evolution of this technology and the various types of implementations that you see, it can become very confusing and overwhelming. You look at the CNCF cloud native, that landscape map that it has, and you look under, I think it's service proxy or service mesh or gateway or those subsets of that map. And even looking at that, you're like, what is all this stuff? Where would I run any of this? Do I need any of this? Now, I'm going to attempt to try to be as clear as possible with what is the roles between a gateway and a service mesh. But as I said at the beginning, there's resources we can point you to that go into more detail. I gave you my contact information at the beginning. I'll put it up at the end. I definitely encourage folks to reach out if there are questions or if I'm not clear enough on what I'm saying here. And I routinely work with folks in the community to help them understand these differences. It's important, right? So we saw that the service mesh is good at handling the east-west traffic or the service-to-service communication traffic, right? So there are things that it does well. Traffic control, so things like rollouts to different versions, rollouts or rather traffic control based on content, maybe headers, maybe the different paths that a user or another service is trying to access. We can do routing tables and route matching and pointing traffic in the right direction. The service mesh is really good at encrypting the traffic between services. So between two services, we can get a TLS, or a mutual TLS between the different services, so that traffic can't be snooped on and so forth. Some service meshes also use that as an opportunity to assign identity to the different service workloads. So you can write policies about what services are allowed to interact with what other services. You can use the service mesh to collect telemetry about the service communication, that east-west traffic, and pull that back to Prometheus or Datadog or some time series collector. But those are capabilities you need at the edge as well in a gateway, right? So there is definitely overlap in these capabilities. And that's fine, right? They are using, in some cases, they are using the same technology. Like I said, Envoy ends up being sort of a foundational piece to a lot of these different these pieces of technology. Now, let's look at the gateway case, where we see the proxy, we see Envoy in a role. This is the most important part, a role that is for service-to-service communication. We're going to see in the gateway case that Envoy plays the role of securing boundaries, which is different than the service mesh service-to-service capabilities. And in that role, Envoy or a gateway needs to play the role, the role of figuring out and deducing trust for traffic that's coming in to this boundary, right? And that could take on all kinds of different security implementations, right? You might do things like, especially, and this is the key part. In an enterprise, there isn't one nice uniform way of doing anything really, I guess, but doing things like security. And there will need to be measures taken for backward compatibility. And you'll need to plug this in somewhere. You don't want to plug it in everywhere. You don't want all the applications to own this responsibility. So typically between boundaries is where you would assign that ownership. And the role of the gateway is then to mediate, right? Between how security is implemented in, let's say, the greenfield applications versus how security is implemented in the brownfield applications, and play that mediation. We have lots of customers who experience this pain point all the time when they try to bring in these types of technologies. So implementing things like OAuth 2 flows, integrating with OIDC, things like LDAP integration. Then stepping out a little bit and saying, well, we need firewall application ruling. We need, whitelist, blacklist, SQL injection detection, all of these types of things at the edge. We need message transformation because the requests coming in from our clients might not be in the right shape that we need for the backend services. We also assign policies and maybe sell usage quotas to different users or track them for different users or parts of the organization differently. And we need to enforce those quotas. We need to enforce rate limiting and spike arrest. And so these are boundary concerns where the gateway would play the role of trying to solve for those boundary concerns. And as you start to build this out, and you go from let's say you go from one Kubernetes cluster to 5, maybe those clusters are in different availability zones. Maybe the different lines of business that deploy their applications, they need to start establishing these boundaries. Maybe you're deploying on premises and in a public cloud. Now you need to set up the gateways to act as boundaries. You're definitely going to need the service-to-service communication features of a service mesh. And you're ultimately going to need something to help manage all that stuff, because that gets very complicated. And so early, as I was putting this slide deck together, and this is something that we work with our customers a lot with, right? This is our area of expertise. Take Envoy and solve the problems that our customers have around service-to-service communication. And the challenges that they have are around multi-deployment, multi-site deployments of applications, managing the security, managing the policies, usages, and so forth, and defining failover rules, locality rules, implementing policies based on identity, controlling traffic, federating these different deployments. And that ends up being a combination of modern gateways, of service mesh, and something to help manage that. That's been a fairly consistent architecture that we've helped our customers get to. And so at Solo, what we see is the heterogeneous infrastructure, on-prem, in the cloud, across multiple clouds, whatever, integrating with legacy existing deployments, existing services. And it kind of first starts with the modernization effort of, well, let's get traffic into these systems. Let's do that with technology that was built for this type of environment. And at Solo, we've built a product on top of Envoy called Glue. Glue, as its name implies, is a way to stitch together these heterogeneous deployments and services, whether brownfield or greenfield, with technology that was built for the cloud and built to go forward, built on Envoy. So Glue is an API gateway built on Envoy. Now, that solves sort of the boundary problems, and you're going to have boundaries everywhere. But that doesn't solve the service-to-service communication challenge. So, in that model, you would use a service mesh and use something like the sidecars that get deployed with the service mesh to handle that those east-west traffic concerns. Now, at Solo, we are service mesh experts, and we do support in production service mesh implementations. So right now, that's Istio. Istio is sort of the dominant leader, and so we do offer production support for Istio, but our knowledge and our expertise goes beyond that. It goes to AWS App Mesh, it goes to Consul, goes to things like Open Service Mesh and so forth. So whatever's Envoy based, that's our core competency at Solo, and building these types of networking architectures is our core competency. So that's all good. But like I mentioned, as you start to deploy this out across multiple different sites, different clusters, and try to build a uniform policy, automation, these types of things, becomes important to have something that's able to understand that and federate all of these different pieces. Run this in a global topology. And so that's where at Solo, we take that part very, very seriously, because that is ultimately what we want to do is solve these problems and make it operational. And our federation plane allows us to do that. The last bit of the puzzle is around extensibility. So getting something like Envoy, getting something like Istio or any service mesh in place is only as good as it's able to fit into existing brownfield scenarios or existing assumptions or compliance or regulatory restrictions. So with our customers, what we've seen is this need to customize the last mile, let's call it, the last 10% of getting Envoy based infrastructures or frameworks into their architecture. And so although we've been able to help them do that by extending Envoy directly or extending a control plane or whatever, WebAssembly is that future direction for solving this type of problem. And this is something that we're heavily invested in. Well, I think we just did an announcement today around a WASM OCI spec that we built to be able to deploy WASM modules into Envoy. We announced the WebAssembly Hub back in December last year as a way of managing the life cycle of WASM extensions for Envoy and so forth. And so we see that as a very important part of the future of something like Envoy, where frankly, Envoy is where all the innovation in this L7 proxy space is happening. Envoy is part of the CNCF, is open, and that things like WebAssembly are happening in that community. Now, lastly, is one of the capabilities that we saw in API management that's very important, that cannot and should not be overlooked, is not part of, let's say, a service mesh per se, is a developer portal. And building the capabilities to allow teams to self-service, to write policies about usage, and expose their APIs at a boundary point, whether that's external to partners, other parts of the organization, or internal. So any of these gateways can be considered, since they're so lightweight, since they're built on Envoy, they're built to deploy into Kubernetes and other platforms, that some of these gateways are internal, can be used as internal gateways. But still being able to elevate some of those APIs for, as I mentioned, usage, that's an important capability as well. So back to the question, can you replace API management with a service mesh? The answer is no, not by itself. There's a lot of other things that go into it. And ultimately, replacing API management isn't the goal, right? Let me back up to this tweet. Right? This is the goal. Deploy our applications potentially globally across different sites, different availability zones, different regions, maybe different clouds, and make sure the traffic is secure. Make sure that the traffic that we can observe our traffic, and write policies about usage and policies about traffic and so forth, and allow people to actually operate it and use it. And so there's more than just service mesh that goes into that. And so as I walk you through here, this is exactly what we're focused on at Solo. So I am going to attempt to demo. I was running into some Google Cloud issues. Oh, okay, we might be in good shape. All right, we got our stuff there. All right, let's take a look. So the first thing that we're going to look at is using. So let's say we start with maybe the pendulum has swung all the whole way, right? And we said, okay, we're doing service mesh. Service mesh is the thing. But we now know, after seeing this webinar, that service mesh doesn't have all of the answers for things that are necessary in a distributed, cloud native architecture like this. So at Solo, one of the projects that we have is called the developer portal for Istio. So this might, if we look at this list here, this might knock out, let's say, that one and that one, right? And maybe a part of this one. I don't know how to, maybe part of this one, right? So this starts to get you going down that path of bridging that gap between what you have in API management and something that works well in a highly distributed environment that is native to service mesh, right? So let's take a look at our developer portal for Istio. If we go here, first of all, we have Istio deployed. And if we just look at our pods here, we see we have a couple of different services, some of the sample Istio ones, a couple pet store services. And if we go over here, I think this is it. Oh, book info. Yeah, pod book info. We see we have the Istio book info sample running here. So what we want to do, what we're going to do here for this demo is we have some APIs and they're running, they're in Istio, sidecars are deployed here, you can see that. What we're going to do is we're going to document them and expose them in a portal. And we're going to wrap them with some rate limiting. We're going to wrap them with some basic auth capabilities. All right. So let's come look at our developer portal for Istio. If I click on APIs, if I click on API docs, we don't have any. Let's add some docs. In this case, it'll be OpenAPI spec docs. If I come here, let's add classic pet store. Let's click create API. Give that a second. Okay. And let's add a new version, updated version of the pet store. Say open, create that API. And that looks good. Now that we've told the developer portal about these different APIs, we want to expose them to outside users. But we want to expose them a little bit differently than how they're implemented in the back end. Or maybe we will expose them the same way, but we want to add additional policies around that. And so that's where we come to define an API product. If I click on API product, let's call this the pet store 0. Next, the domains will be pet store dot what is it? My DNS.me, I think. And Let's give it an image. Next. Now here we can just pick the API doc that applies. Right. So, but we want to take a little bit more complicated use case where we're not just going to expose it exactly how it is to end users. What we're going to say is for the search capabilities from the older pet store is what we'll expose. But then for adding a pet, we want to route that to the newer service. So we're going to kind of mash up these two APIs in the back end to expose a single API on the gateway. So we'll give that a second. Giving you a heads up already. I've had some trouble with our cloud provider today for some reason. All right, I think we're hopefully okay here. So one thing that we got to do is define the routing for the different APIs. So we'll do that here. We'll give a default route, but we can also come down here and specify the route for each individual path in the API. We'll just give it a default route at the moment and click save. And we'll give it a second to reconcile in the back end. So one thing I do want to point out here is that everything that we define through this UI is actually also available as custom resources. So anything that we do here can also be done in a Git-based workflow. So if we were going to come here and look at our API products that we have, we can see that indeed a pet store API product was created. Now, if we come back here to APIs, we can see that our APIs have been created, or our API product has been created. And under the covers, we created a virtual service for Istio. Let's see, get virtual service.networking. See, we've automatically created this pet store virtual service, which means that I should be able to, if I set up all the DNS stuff correctly, call this service. And what it's done is it's set it up on the Istio ingress gateway. So it's automated. So we're starting to turn the ingress gateway for Istio into a lightweight API gateway. And so from here, what I can do is I can create a portal now. So we'll just call this the pet store portal. Let me make sure that I'm doing this demo on the right order. Actually, before we do that, let's come over here. For our pet store API product, we do want to implement rate limiting. So let's say our rate limiting is going to be, let's see, pet store plan. We'll say 5 requests per minute. Let's say that. Create that usage plan. Now, when we expose it in our portal, which we'll do here in a second, so we'll call this the pet store portal. Call this APIs.myDNS. We can add some images just to give it a little bit more color. We'll give it an icon as well. Now we'll say we're going to add the pet store, and we'll add a particular user to this portal. And again, all of this stuff is done as CRDs under the cover. So now we have our pet store portal, and we have our pet store product. So now if I come to the portal and click on it and go into it, you can see we have a simple portal here, which is customizable. So you can make it look however you like. If we look at the APIs, we see our pet store API is indeed there. If I click on this, we can get the documentation for it. Now from here we can call it, and we can, and actually it might be useful to show that we can create API keys for being able to call it. So now that I've added it to the portal, I've added a rate plan around it. If I try call it, it shouldn't let me. It doesn't. So to be able to call it, we need to pass in this API key. And I can do that just by clicking here. We'll give it an API key, authorize. And then now if I come into API/pets and say try it out, execute, if I call it using the API keys and passing in the API key, then it works, right? So again, we've set up Istio's ingress gateway to be able now to perform, let's take this. We can see it's performing an auth challenge. It has to have the API key, otherwise it won't work. But if we call it too many times, we'll eventually see the rate limiting kick in. So we've added rate limiting to Istio's ingress gateway. So we've sort of bridged the gap there. But that's not everything, right? So come back to our list here. There's still things like security, flows, web application firewalling, telemetry collection, and so forth. And that's where our API gateway built on Envoy called Glue fits into the picture. So Glue is a full-featured API gateway built to run in Kubernetes, cloud native, highly decentralized, no extra databases, very minimal operational overhead, and solves those problems around. If we look at our security, authentication, authorization, being able to plug into LDAP, and we have the API keys, but we also have OAuth, OPA, Open Policy Agent for doing authorizations, and you can write your own plugins as well. So I highly encourage you, and the last part is the Glue plays very nicely with Istio, basically extends Istio's capabilities, but lives natively as a gateway for Istio, ties in with mutual TLS and that kind of stuff. So I realize here that I'm running out of time, but I definitely want to leave you with, let's come back down here. Here, I'll leave my contact info. Definitely reach out to me if you have questions outside of this. I also want to leave with some additional resources and links for some of the stuff that we talked about here today.
Yeah, and I can also add those links into the follow-up email as well, so folks don't have to try to screenshot this screen.
Yep.
So Christian, do you think we can do 2 quick questions?
Yeah, let's please do. I made the rookie mistake of burning my time here. I didn't leave time for questions. I apologize for that. But yes, let's definitely have some questions.
Yeah, I've got 2 here, and then we can follow up with the other ones in a blog post or something.
Sure.
First one is, do you see organizations like enterprises typically using a single large mesh or several smaller meshes with an API management layer in between?
That's a great question. And that is precisely the type of architecture that we specialize in helping folks build. So basically what it ends up looking like is a single mesh is, it really depends on definitions here. Let's take Istio, for example. What we recommend is folks deploy Istio in the replicated control plane manner, which means each logical boundary has its own control plane. And by extension, that boundary should also map up with the other properties of the failure domains that you're trying to limit. So for example, Kubernetes itself is a single failure domain for deployment, for configuration, for security, and so forth. So ideally, you would deploy a single Istio control plane there. Across clusters, you'll have separate control planes. And Now, the problem with that is the operational overhead and management of that. From a security standpoint, from a failure domain standpoint, a highly availability standpoint, that is the right approach, but that puts a lot of burden on operations. And we didn't talk about it today, but that's where our Service Mesh Hub product comes into play. So when you start to federate these different mesh deployments across different installations, across different clusters, the operational overhead of keeping those viable is not zero. So Service Mesh Hub was built to solve that exact problem. So from a mesh capability standpoint, federated meshes. From a cross-boundary, cross lines of business, we typically see internal gateways. So it's where something like Glue would fit in, across availability zones or regions. We might see, ingress gateways. Again, a Glue would fit there, and especially across clouds. So then when you have the gateways at these different boundaries, that becomes an operational overhead, right? But so with Glue comes with, or Glue has the option to have federation capabilities. So you can kind of get a holistic management plane over the gateways as well.
Okay, and one last question is, when you mentioned internal gateways, and the question here is, why would I need an internal gateway when I already have sidecar proxies?
Okay, so that's a great question. It obviously it illustrates the fact that I didn't clarify this well enough. So I'll try to say it again. So between boundaries, between lines of business, for example, think in your organization, different lines of business. Within the line of business, the sidecar proxy can correctly handle the traffic from one service to another. But once you start to cross those boundaries, a particular line of business might want to say, hey, you can't just call me directly. I want rate limiting. I want OIDC. I want request transformation. I want all of these different capabilities that you would expect at the boundary to be implemented. And the service mesh, that's not a capability that it has, nor would you want it. You don't want all parts of the organizations, their assumptions about how requests come into them, or their peculiarities in terms of transformation and so forth, leaking into every single sidecar across the organization, right? Just that's a huge mess. That we want to avoid that. So you will want structure, and you will want those boundary enforcement points only where necessary. And so for that, an internal gateway is the right implementation.
Great, and we are just 2 minutes over, but thanks again, Christian, for the talk and demo today. And for everyone with all your questions, we'll try to get as many of them answered offline as possible. And we will see you at the next online event, which is the end of this month. We're actually having live online service mesh, multi-cluster service mesh workshops. So you can go to our events page and register for those. So with that, we'll get the recording and slides out to everyone shortly. And thanks again for joining. See you next time.
Thanks.
Bye.